we are going to learn about how to perform hand reams and fit taper pins.
At the end of this demonstration, you will be able to file the shape and size as per drawing, mark square and taper dowel pin location, step drill to ream taper pin hole and drill relief hole, chain drilling. Fix taper dowel pin and cheese head screw as per drawing. Fit part 2 in assemble setting as per drawing. Tools required: vernier height gauge, vernier caliper, taper dowel pin. Equipment required: lathe machine. Materials required: raw material, oil. Before starting job, there are some preliminary checks to be made. Those are as follows. First, check the raw material using steel rule. File the part 1 for the overall size, maintaining parallelism and perpendicularity. File the part 2 for the overall size, maintaining parallelism and perpendicularity. File the part 3 for the overall size, maintaining parallelism and perpendicularity. Once filing all the 3 parts has been completed, then prepare all the parts for the markings. Mark off part 1 with vernier height gauge as per drawing. Mark off part 2 with vernier height gauge as per drawing. Part 1 and 2. Check the given raw materials for its size. File raw metal to size 60 into 60 into 9.5 mm in 2 pieces and check the dimensions using vernier caliper. Check flatness and squareness using a tri-square. Apply marking medium and mark off square and enter line for dowel pin holes and cheese head screw holes and punch witness mark and center punch marks on the job. The raw material has been checked, all the parts have been filed, and then they have been marked with vernier height gauge, and at last they have been punched witness mark. Now, all the preliminary checks have been done, we are good to go. Place part 2 on part 1 assemble and clamp the setting with parallel clamp and check the squareness of the assembled parts. Fix center drill in drilling machine and center drill to locate all the spot of hole position as per drawing. Fix diameter 4 mm drill in drilling machine and drill a through hole in the place of taper dowel pin assembly. Similarly, fix diameter 5.7 mm drill rod step hole to the depth 2/3 portion of the drilled hole and fix diameter 5.7 mm drill and step drill hole to the depth of 1/3 portion of the drilled hole in the place of taper dowel pin assembly. Fix taper pins reamer in tap wrench and ream a step drill hole to the taper hole to suit taper dowel pin in the assembly without disturbing the assembly setting. Use plenty of oil while reaming. Fix taper dowel pin in the reamed taper hole through push fit. Similarly, repeat the above working steps and complete the above procedures to fix another taper dowel pin in the assembly through push shift as per drawing. Fix diameter 6.0 mm drill in drilling machine and drill a through hole in the place of cheese head screw assembly. Fix diameter 10 into 6.0 mm counterbore tool and counterbore to the depth of cheese head screw head thickness in part 2 top blade and cut M6 internal thread in the place of cheese head screw assembly in base plate. Fix M6 into 18 mm cheese head screw in the internal threaded hole. Similarly, repeat the above working steps and complete the above procedure to fix the outer cheese head screw in the assembly. Fix diameter 3 mm drill in drilling machine and drill relief holes as per drawing. Fix diameter 6 mm drill in drilling machine and drill chain drilling to remove unwanted metal in internal square, part 1 and part 2, base and top plate. Disassemble the setting from the drilling machine table and chip and remove the unwanted metal using chisel and ball peen hammer in part of base and top. Reassemble the part 1, base and top along with taper dowel pins and cheese head screw and file internal square to size and 90-degree angle and measure the dimensions with vernier caliper. Follow safety precautions while performing drilling and chipping operations. Now, we have successfully created the first part and the second part. Next, we will create the third part. File part 3 raw metal to size in square bar 24 into 24 into 25 mm and check the dimensions with vernier caliper. Check flatness and squareness using a tri-square. Fit part 3 in push shift in the assemble part 1 and part 2 base and top. Disassemble all the parts and finish all the surfaces and remove burrs from all corners of the parts of assembly. Reassemble all parts and fit part 3 in push fit. Once all the fitting is done, apply oil and preserve it for evaluation.
Let's have a recap of what we have learned today. We have learned to file to shape and size as per drawing, mark square and taper dowel pin location, step drill to ream taper pin hole and drill relief hole, chain drilling, fix taper dowel pin and cheese head screw as per drawing, fit part 2 in 1 assembled setting as per drawing. Thus, we have learnt how to perform hand reams and fix taper pin. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. Today we are going to learn about drilling and reaming holes in correct location, fitting dowel pins, studs and bolts.
At the end of this demonstration, you will be able to file to size as per drawing, mark and punch hole locations, drill, ream, counter bore as per drawing, cut M6 internal thread to suit bolt and stud, assemble as per drawing. Tools required: vernier height gauge, vernier caliper, equipment required: lathe machine, materials required: raw material, oil. Before starting job, there are some preliminary checks to be made. Those are as follows. First, check the raw material using steel rule. File the part 1 for the overall size, maintaining parallelism and perpendicularity. File the part 2 for the overall size, maintaining parallelism and perpendicularity. File the part 3 for the overall size, maintaining parallelism and perpendicularity. Once filing all the 3 parts has been completed, then prepare all the parts for the markings. Mark off part 1 with a vernier height gauge as per drawing. Mark off part 2 with a vernier height gauge as per drawing. Mark off part 3 with a vernier height gauge as per drawing. Once you are done with marking off all the parts with vernier height gauge, the next step to follow is punching. Punch drill hole marks in part 1. Punch drill hole marks in part 2. Punch drill hole marks in part 3. The raw material has been checked. All the parts have been filed and then they have been marked with vernier height gauge, and at last they have been punched witness mark. Now, all the preliminary checks have been done, we are good to go. Fix diameter 5.8 mm drill in drilling machine and drill through holes and ream the holes of diameter 6 mm reamer in part 1 and 2. Clean the reamed hole with soft cloth and fit diameter 6 mm dowel pin. Similarly, drill, ream and fit diameter 6 another dowel pin with the same setting in part 1 and 2 as shown in figure 1. Then, fix diameter 5 mm drill in drilling machine and drill through hole for M6 hexagon bolt assembly. Similarly, drill diameter 5 mm drill hole in part 1 and 2 for another M6 hexagon bolt assembly. Counterbore to the depth of fixing M6 Allen bolt head side in part 1 as shown in drawing. Separate part 1 and 2. Hold countersink tool in drilling and machine and countersink 1 into 45 diameter in the place of cutting internal thread on both sides of part 2. Thread has been cut in part 2 only. Cut M6 internal thread in the place of hexagon bolts assembly in part 2. Clean the threads without burrs. Now, we have successfully created the first part and second part. Next, we will insert the third part. Reassemble part 1 and 2 and set part 3 as shown in figure 2 and clamp it with parallel clamps. Then, fix diameter 5.8 mm drill in drilling machine and drill through hole ream 6 mm for dowel pin assemble with part 1 and 3. Fit diameter 5 mm drill and drill 2 through holes in the place of studs assembly in part 1 and 3. Separate part 1 and 3. Fix diameter 6 mm drill and drill through holes in part 1. Countersink 1 into 45 diameter in part 3 and cut M6 internal thread. Thread has been cut in part 3 only. Clean the thread and reassemble part 1 with part 3. Fix M6 bolt along with plain washer and tighten it using suitable spanner. Disassemble all the parts 1, 2 and 3 and finish with file and deburr on all surfaces of the job. Reassemble all the parts 1, 2 and 3 with dowel pins, hexagon bolts, stud and nuts. Since we have completely reassembled all the parts with dowel pins, hexagon bolts, stud and nuts, now apply a thin coat of oil and preserve it for evaluation.
Let's have a recap of what we have learned today. We have learned to file to size as per drawing, mark and punch hole locations, drill, ream, counter bore as per drawing, cut M6 internal thread to suit bolt and stud, and assemble as per drawing. Thus, we have learned to drilling and reaming holes in correct location, fitting dowel pins, stud and bolts. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello everyone. In today's video, we are going to discuss how to check washers, gaskets, clutches, keys, jibs, cotter, etc. and replace them.
Objectives. At the end of this video, you can be able to replace washer on gasket, replace clutch and keys, replace jib, cotter and circlip, replacing the above components. Replacing washer. Remove nut using correct size spanner. Remove the worn out washer from the assembly. Place the correct size washer. Tighten the nut with washer. Skill sequence. Types of washers. Objectives. This will help you to state the purpose of washers, identify the types of washers, state the uses of each type of washers, specify the washers as per BIS, Bureau of Indian Standards. Purpose. It is a common practice to provide washers under the note in bolted joints. Washers help to increase the frictional grip, prevent damage to the workpiece, and distribute force over a large area, prevent loosening of nuts due to vibration. There are different types of washers available. They are plain or flat washers, taper washers, spring washers, tab washers, tooth lock washers. Plain or flat washers. These washers are used for bolting assemblies with fair surfaces. The diameter, thickness, and the bore diameter are proportional to the diameter of the bolt, IS 2016. Plain washers are available as machined or punched washers. Machined washers. These washers are used for assemblies using machine components. These washers are available with chamber on one side or on both sides. They are heat-treated or ground-punched washers. These do not have chambers and are most commonly used in structural fabrication work. Tapered washers. These are used in structural assemblies with tapered surfaces like inside of I-beams, channels, etc. These washers help the bolt head or nut to sit square to the hole. Spring washers. Spring washers are used under nuts to prevent slackening of the nuts due to vibrations. They are made of spring steel and when compressed, they create tension between the bolt and the nut. Tab washers. These washers are used for locking the nuts. Tooth-locked washers. These washers have serrations, cut and twisted. When placed between the nuts and the assembly, these washers exerts friction on both the contacting surfaces. This prevents the nuts from slackening. Specifications. The Indian Standard IS 2016-1967 designates a washer by name, type, size and number of the standard and material. Example, a machined washer of size 10.5 mm made of brass shall be designated as machined washer 10.5 IS 2016 brass. Note: for detailed specification of different type of washers, refer to the following IS specifications. Taper washer IS 5374 and IS 5372. Tab washer IS 8068. Tooth lock washer IS 5371. Plain washer IS 2016. Replacing gasket. Remove the damaged gasket. Clean the surface of the base and the cover plate. Place the gasket on the base plate and press firmly. Assemble the circuit. Adjusting the clutch. Remove the both side covers of feed gear box using Allen keys after switch off the power supply. Remove the terminals by using suitable spanner. Use a bent tubular spanner to remove the carbon brushes. Remove the circuit from the spline shaft. Take out the clutch with spline shaft from the unit by using M12 bearing puller set. Place the assembly on workbench. Clean it properly. If not getting proper engaging and disengaging of clutch, dismantle the clutch unit and remove clutch plate. Identify the flowing electrical and mechanical faults. Check the gap with feeler guards between clutch plates and ensure that the gap should be as mentioned by the original equipment manufacturer. Check the spline shaft and ensure that the splines are proper. Assemble all the parts and once again check the unit on a workbench. If found satisfactory working of clutch assembly, mount it into the feed gearbox of machine. Seated the circlip, carbon brushes and terminal. Fix the side covers by using Allen key and check the working of clutch assembly by switch on the machine. Adjust clutch pressure. Objective. This will help you to adjust the pressure of a multi-disc clutch. Switch off the electrical mains of the lathe before opening the lid of the headstock. Remove the top lid of the lathe headstock by unscrewing the Allen head bolts. Take out the clutch lever along with the lid. Release the index pin from the annular disc. Rotate the annular ring to get the desired friction. If the nut is tightened too much, the friction will be more and vice versa. Insert the index pin to the annular disc hole through the adjusting nut firmly. Replace the gasket of the top lid. Assemble the top lid by keeping the clutch lever in position. Tighten the Allen screws of the lid using the Allen key. Test the functioning of the clutch in engaging and disengaging positions.
I hope you can check washers, gaskets, clutches, keys, jibs, quarters, and other components after viewing this video and replace or repair them as necessary. Thank you for watching. Hope you have a fantastic day.
Hello everyone. In continuation to be discussion on washers, gaskets and clutches in the last video, we will now talk about keys, jibs, gib strips, cotter and circlips.
Task 4. Replacing key. Step 1. Assemble hub and shaft with parallel key. Step 2. Assemble hub and shaft with tapered jib head key. Parallel key fitting. Step 3. Deburr the keyways in the shaft and the hub. Clean the keyways. Step 4. Check the dimensions of shaft and hub and keyways using precision instruments. Outside dia of shaft, inside dia of hub, length, width and depth of keyway as per the drawing. Step 5. Select a length of key steel of suitable cross-section depending on the size of the key. Step 6. File radius at one end of the key and cut to a length plus 1 mm of the key and file other end of the key. Ensure that the key is chamfered all around in its bottom side edges. Step 7. Check the key width to suit the keyway in the shaft. Draw file the key so that it is slide tab fit or light keying fit K7 height 6 with the keyway on the shaft. Step 8. Check the key for slide tab fit with the keyway in the hub. Step 9. Apply Prussian blue on all sides and bottom portion of the key so that proper bearing of key on the keyway is ascertained. Step 10. Insert the key in the keyway of the shaft and tap with a lightweight soft hammer. Step 11. Tap the hub on the shaft and remove the hub from the shaft. Check the key and note the high spots where the key has made contact with the keyway of the hub. Step 12. Lightly file the high spots away. Top of the key should be approximately 0.1 mm clear. Step 13. Repeat the fitting and filling operation until the hub is fit onto the shaft to the desired position. Task 5. Replace or adjust jib. Step 1. Removing the adjusting screws from the dovetail slide. Step 2. Dismantle the jib from the cross slide. Step 3. Clean the slide surfaces, adjusting screws, nuts and jib thoroughly. Step 4. Inspect all the parts for and check any damage. Step 5. Lubricate the slideways. Step 6. Assemble the jib. Step 7. Tighten the adjusting screws to give the correct freedom required in the assembly. Step 8. Lock the movement of the adjusting screw by the check nut. Adjust the jib strip. Objective. This will help you to adjust and align the jib strip in a lathe. Step 1. Loosen the lock nuts. Step 2. Remove the set screws. Step 3. Pull the jib out. Step 4. Clean all the parts. Step 5. Check the straightness of the jib using Prussian blue. Step 6. Scrape the jib to get even surface to prevent stick-slip motion of the cross slide. Step 7. Lubricate all the parts. Step 8. Assemble the jib into the dovetail slide and position it. Step 9. Adjust the screws and eliminate the clearance between the slides for getting the correct freedom required in the assembly. Step 10. Lock the movement of the adjusting screws by the checking nut. Step 11. Hold the jib in correct position firmly while locking the check nuts. Step 12. Check the function of the cross slide. Task 6. Replace cotter. Step 1. For removing cotter from work unit, loose the nut slightly, then slowly strike with soft hammer. Step 2. Then loose the nut completely, pull the cotter pin. Insert the new cotter pin in the hole, strike with hammer. Step 3. After tightening the pin, fix it. Task 7. Replace circlip. Step 1. Assemble external circlip using cone and compression bush. Step 2. Assemble internal circlip using cone and compression pin. Step 3. Assemble external and internal circlips using pliers. Step 4. Dismantle external and internal circlips using pliers. During assembly, circlip is to be spread or closed as far as it is necessary for positioning on the shaft or installing in the housing board. Assemble external circlip using cone and compressor brush. Step 1. Circlips without assembly holes are best assembled by means of cones. Step 2. Place the cone over the shaft in which the circlip is to be fixed. Step 3. Place the circlip over the cone. Step 4. Place the compression bush over the circlip. Step 5. Press the compression bush by suitable means depending upon the size of the circlip slowly and smoothly until the circlip is seated in the groove. Assemble internal circlip using cone and compression pin. Step 1. Place the cone over the board in which circlip is to be provided. Step 2. Place the internal circlip in the tapered bore of the cone. Step 3. Place the compression pin over the circlip. Step 4. Press the compression pin slowly and smoothly until the circlip is seated in the groove in the bore. Assemble and dismantle circlip using pliers. Step 1. Select suitable circlip pliers depending upon the circlips to be used, external or internal. Step 2. Remove all sharp edges from the circlip and check for the crack if any. Assemble internal circlip. Step 1. Hold the internal circlip with help of an internal circlip plier. Step 2. Press the circlip with the help of the plier so that its diameter will be smaller than the hole diameter. Step 3. Insert the circlip in this position in such a manner that it will sit squarely in the groove. Step 4. Take out the plier. Assemble external circlip. Step 1. Hold an external circlip with the help of an external circlip plier. Step 2. Press the external circlip plier so that the circlip will enlarge in diameter. Step 3. Slide the circlip on the shaft in the enlarged position until it is set in the shaft groove. Step 4. Ensure that the circlip sits squarely in the groove. Step 5. Take out the plier. Step 6. For dismantling the internal and external circlips, the above procedure can be reversed and applied.
I hope you can check washers, gaskets, clutches, keys, jibs, quarters, and other components after viewing this video and replace or repair them as necessary. Thank you for watching. Hope you have a fantastic day.
Hello, welcome to the session on dismantling, assembling of different types of bearing and check for functionality, part 1. Let us look at the objectives of this session. At the end of this session, you will be able to dismount a shaft from pedestal block, mount a shaft on pedestal block, the required tools and materials to dismount and mount shaft from pedestal block are bush bearing, ring spanner, cleaning brush, kerosene, bunion cloth, bench vise, flat file, lubricating oil, hammer, safety goggles, gloves. Now, let's look at how to dismount and mount a shaft on pedestal block. Ensure to wear safety tools while dismantle bush bearing to prevent from injuries and also ensure a safe work environment. First, dismantle the cap of the block by using a proper ring spanner. To remove, hold the shaft with left hand and fasten the nuts by the right hand. remove top shell along with the cap. Then, remove the shaft and bottom housing. Now, clean the shells, cap, shaft seating, that is journal, and bottom housing thoroughly with small brush with kerosene. After cleaning all the components, wipe them with clean bunion cloth. Do not use cotton waste to wipe out component. Now, check the shells and journal for any damage, scoring mark, etc. Also, check the cap, bottom housing, and fastening bolts and nuts for any damage and wear. In case of any damage in the components, replace them with a new one before assembling. Check the ovality of the bearing bore by fixing cap on the bottom housing. To remove the ovality, remove the cap by unscrewing fastening bolts. File the bearing caps equally with flat file to compensate for the ovality by holding the cap into the bench vise. Then, fit the two halves of the bearing back together. Remember that when the bolts are fitted, the load should be taken by the caps and not by shells. Now, fit the shells to their housings. Check that the fitting is correct and the oil holes align with those of the housings. Apply marking medium around the journal area and place it into bottom shell for uniform contact. If the number of color marking on the bottom shell is more, it indicates that the shaft having proper contact with bottom shell. Otherwise, scrape the shell to have more number of color marking. Now, coat all the parts with the correct grade lubricant to reduce friction. Then, place the journal on the bottom housing place the top shell and cap on the shaft. Finally, tighten the bolts firmly by holding the shaft using ring spanner. After mounting pedestal block, clear all tools around the work spot. Let's recap the key points discussed. Remove the top shell along with the cap. Remove the shaft and bottom housing. Clean all the components and wipe with clean bunion cloth. Check the alignment of oil holes while fitting. Lubricate all the parts with the correct grade. Assemble the parts in the sequence and finally tighten the bolts. This brings us to the end of the session. Hope you have gained a good understanding about dismantling, assembling of different types of bearings and functionality. Checking Part 1. See you in the next session. Hello. Welcome to the session on dismantling, assembling of different types of bearing and check for functionality, Part 2. Let us look at the objectives of this session. At the end of this session, you will be able to dismount ball bearings having interference fit on the shaft. Dismount ball bearings having interference fit in the housing. Mount ball bearing. The required tools and materials to dismount and mount ball bearings are ball bearing, arbor press, bearing puller, kerosene, bunion cloth, hammer, spanner, lubricating oil, soft bristle brush, vernier micrometer. There are 3 methods to dismount ball bearings having interference fit on the shaft. First method is by using arbor press or hydraulic press. Initially, place the bearing with the shaft on the arbor press or hydraulic press. Place a ring or 2 parallel blocks of equal size to support the inner ring of the bearing. Put a dummy between the ram and the shaft. Press the shaft gently to come out of the bearing. Support the extracted shaft by hand to prevent damage. Do not apply direct hammer blows on the bearing. Second method to dismount ball bearings having interference fit on the shaft is by using bearing puller. First, fit the bearing puller's spindle on the center hole of the shaft. Place the legs on the bearing. Then, slowly tighten the spindle of the puller by a spanner to make the puller to take the strain. Remember to use a keeper puller plate along with the puller when the puller's legs tend to engage with the outer ring of the bearing, if the bearing is to be used again. In the case of small bearings, it can be removed easily by using a puller or with a metallic sleeve using mild hammer blows. To dismount small and medium-sized bearings, use a hammer and a sleeve by butting the lock nut or the inner ring. If the nut is located inward, place the sleeve against inner ring. Then, use hammer blows for dismounting. A special type of puller with bracket can also be used to dismount the bearing. This type is used to apply pulling force on the inner ring of the bearing. Next, let's learn to dismount ball bearings having interference fit on the housing bore. The ball bearings can be dismounted by using sleeve and using drift. To dismount using sleeve, place the wheel on two wooden blocks and fit a suitable sleeve on the face of the bearing. Then, apply pressure on the sleeve to drive out the bearing. This type of dismounting can be done for a housing without any shoulder. For a housing with a shoulder between the bearings, use a soft metal drift to strike the bearing in different position to drive out. A suitable puller can also be used to dismantle the bearings. To dismount self-aligning ball bearings, swivel the inner race by fitting the legs of the puller on the outer race and tighten the screwed spindle to extract the bearings. Once the bearings are dismounted, clean them with soft bristle brush using kerosene or naphtha. Then, wipe off the bearings with bunion cloth. Do not use cotton waste for cleaning or wiping off the bearings. After wiping, inspect visually for corrosion, damage in cage, raceways, rolling elements, and also the inner and outer races. Then, gently lubricate the bearing. Also insert the bearing around the fingers of the hand and rotate gently to check the smooth rotation of the bearing without any distraction and noise. If there is any seal, replace it. To mount the ball bearings, clean and measure the shaft diameter to check the necessary interference fit. To measure the shaft diameter, use a vernier micrometer for shaft fit and a vernier inside micrometer for housing fit. Then, clean the shaft for mounting. Place the correct sized sleeve on the inner ring of the bearing. Using common hammer, apply hammer blows. Slowly drive in bearing until the metallic sound is heard. The same process should be adopted for the housing fit by selecting the proper sleeve to sit on the outer ring. Use an arbor press wherever possible because it is particularly suitable when small bearings are frequently mounted. Then, lubricate the shaft. Place a mounting sleeve between the bearing and press resting it on the ring with interference fit. Finally, drive in the bearing into the shaft by applying force by the press. Let's recap the key points discussed. Dismount ball bearings having interference fit on the shaft by using either puller, arbor press, or sleeve and hammer. Clean the dismounted bearings with soft bristle brush using kerosene or naphtha. Lubricate the bearing and drive in bearing until the metallic sound is heard. Drive in the bearing into the shaft by applying force by the press. This brings us to the end of the session. Hope you have gained a good understanding about dismantling, assembling of different types of bearings, and functionality checking part 2. See you in the next session.
Hello students! Now we are going through the topic of scraping the external angular mating surface. It is one of precision machining technique used to ensure accurate alignment and proper fit between two mating surfaces in angular contact applications. The process involves carefully removal of material from the mating surface to achieve the desired angle and surface finish. To check the angle of the mating surface, a sine bar is commonly used. A sine bar is a precision measuring tool consisting of a hardened steel bar with accurately ground parallel surfaces. It is used in conjunction with a dial indicator or a height gauge to measure the angle of the scraping surface. At the end of this exercise, you shall be able to file to flat and square, mark as per drawing and punch witness marks, prepare part 1 and part 2 as per drawing by scraping, and check angle with sine bar and dial indicator.
This topic involves the use of several tools and equipment. Here are the main tools commonly used. Scraper. This device used to produce key slots, all lines and parallel surfaces. Sine bar. This equipment used to measure parallelism and angularity of surface with supporting tool called dial indicator. Dial indicator. It is the high precision device used to measure surface, parallelism, waviness and angularity with highly accuracy. Height gauge. It is a special precision equipment used to measure the vertical height of the job by using beam, base and scrapes. while on measuring the gauge is placed on the main surface block used to give datum to the base. Precision parallels or gauge blocks. In these, accurate gauge blocks are used as joining equipments while measuring of angle and height of the job, etc. While working, a special property ringing is used to align the blocks. Vise or fixture. This type of tools are used to hold the job rigidly while the time of machining and some other fitting and filing operations. Cleaning and deburring tools. These are the primary tools used in the process of scraping the external angular mating surface and checking the angle with the sign bar. Proper selection, calibration, and handling of these tools are crucial to achieving precise and reliable results, and also these type of tools used to play major role to measure the surface finish and accuracy. Check the raw material for its size. File to flatness and squareness to overall size. Mark dimensional lines as per drawing and punch witness marks. Cut off the material into two pieces, part 1 and part 2, by hacksawing as shown in figure 1. File part 1 to size and shape, maintaining the dimensional accuracy plus or minus 0.02 millimeters. Check the dimensions with vernier caliper. Check the angle 19 degrees 17 minutes with vernier bevel protractor. Similarly, file part to size and shape and also to angle 19 degrees 17 minutes. Apply Prussian blue evenly on the surface plate to check high spot on angular surfaces. Place part 1 and part 2 angular surfaces on surface plate and move gently. Take the job from the surface plate and notice the high spot, Prussian blue spotted marks, on angular surfaces. Hold the job in a bench vise, scrap and remove the high spots with a flat scraper. Repeat the process until the Prussian blue cover the entire angular surfaces of part 1. Similarly, scrape part 2 and maintain the angular surface without high spot and angle 19 degrees 17. Clean the surface plate, sign bar and slip gauge with soft cloth. Select the slip gauge to the height of 33.0 to 4 millimeters. Set the part 1 in sign bar and clamp it properly. Fix the dial test indicator in the stand. Set the dial test indicator plunger on the angular surface of the job. Set the dial test indicator pointer in 0 position. Bring the slip gauges under the sign bar roller. Move the dial test indicator from one end to other end and check the parallelism of the angular surface. If the dial test indicator pointer does not move plus or minus side and stand still in 0 position, means there is no deviation in the angular surface of job. Instead of that, the dial test indicator pointer moves plus or minus side, means there is a deviation in the angular surface of the job. If you notice any deviation, correct the parallelism of the surface of the job by using suitable slip gauge and calculate the actual angle. dismantle the setting, clean all the instruments, and keep it in proper place. Make part 1 and part 2 angular surface and apply thin coating of oil and preserve it for evaluation. Tan theta is equal to opposite side divide by adjacent side is equal to 35 divide by 100 is equal to 0.35. Hence theta 19 degrees 17 minute 20 seconds. As per trigonometric table, tan theta is equal to 0.35. Theta is equal to tan inverse 0.35. Theta is equal to 19 degrees 17 minute 20 seconds.
The topic revolves around scraping an external angular mating surface and checking the angle using a sine bar. Scraping the surface involves the removal of material to achieve a precise angle. This process involves several steps including cleaning the surface, setting up the sine bar on a flat reference plan, mounting the workpiece and positioning a dial indicator to measure the deviations. The angle is adjusted by using shims or other means to achieve the desired angle on the workplace. The scraping process is carried out using a scraper tool, applying even pressure and making control strokes. The angle is periodically checked using a precision level or an angle measurement tool. The sine bar serves as a reference surface and aids in setting up the workpiece of the desired angle. It helps ensure accurate measurements and adjustments during the process. The dial indicator helps in measuring deviations from the desired angle. Once the desired angle is achieved, the surface is cleaned to remove any debris and the angle is rechecked for accuracy. So, the topic emphasizes the steps involved in scraping an angular mating surface, the use of a sine bar for angle measurement, and the importance of precision in achieving the desired angle for proper mating of component. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care.
In this continuing series of lecture on the reinforcement detailing of the various RC element in a structure, I will be covering the reinforcement detailing requirement of the RC slab in this particular presentation. Now, going ahead, the reinforcement detailing of the slabs are done based on its support condition. We will now discuss the important aspect of the slab detailing in our lecture. Now, first coming to the detailing check, we have